Hi guys, so we have the math lesson from Monday actually, and then I'm going to put up the one from Wednesday as well. I'm not sure how much you guys understood of it. So we're going to start like we always start. We're going to do the notes first. So we have lesson 12.2. The name of it is Experimental Probability of Simple Events. All right, so that is our title for our page, Experimental Probability of Simple Events. If at any time you want to stop so that you can write something down because I'm talking too fast or I'm writing too fast or I'm going on too fast, you can always pause the video. That's fine. Okay, so when we're talking about experimental probability, we're talking about how likely is it that something is going to happen. Whenever we talk about this, we always know that so let me see. We'll end up in a situation like this. You know, dice. Think of your little die. It has 6 sides. So since it has 6 sides and you roll the dice every single time, it will come up on either a 1, a 2, a 3, a 4, a 5, or a 6. You have the same chance of it rolling on each one of those. So we would say it's the same probability of coming up, the same experimental probability. Now, typically when we're talking about experimental probability, we're actually talking about in science. So we're saying how likely is it for something to happen? So I have clouds in the sky. How likely is it that it is going to rain? Well, let's see. We had clouds in the sky every single day this week. It rained, what, twice, maybe? So 2 out of 7 days, that's our probability. That is our experimental probability for how much it's going to rain. So we have, for this one, our definitions. We have a couple of definitions. We have experimental probability, experimental probability. And yes, this is not as wide as my whiteboard at the school, and as such, we're going to end up having some issues there. That is equal to how often it occurs. So in this case, we were talking about the rain, how often it rains over the total number of trials. Over total, I'm going to put down total times tried. Over total times tried. So since we had the clouds on 7 days, that was 7 days we tried seeing what would happen if we had clouds in the sky. So under total times tried would be the 7. How often it occurs would be the 2, because it actually rained 2 times. Now, since it only rained 2 times, 2 out of the 7 times, it has a 2/7 chance of raining. If we were talking about how often it didn't rain, but we had clouds, we then end up with a 5/7 chance of it not raining, because 5 out of the 7 days, it did not rain. Does that make sense to you? Okay, so we can make predictions using our experimental probability. If we know what's going to happen, if we think we know what's going to happen, we can often use part of an experiment to go, you know what? When I sit here and I have that die that I was talking about earlier, where I have the 6 sides, and if I rolled it over and over and over again, I would find out that it occurs about 1 in every 6 times. So like the number 2. So I would know that that was what it was. And I wouldn't have to then go through. The probability doesn't change, it would stay there. For the rain, the probability that we would come up with is there are clouds in the sky. That means I have a 2/7 chance of it raining, and I have a 5/7 chance of it not raining. 5/7 is bigger than 2/7, so maybe I shouldn't worry so much about it raining, because it's more likely that it's not going to rain. Now, it all depends what kind of clouds are in the sky, of course, but I'm just using this as an example. So, when we have something like what was on page 375, where we're talking about outcome and the numbers of times, we sat there and I actually did the experiment with a cup and throwing it multiple times. Tim helped me out with it. He's better at getting it to actually land upright than I am. So we ended up with this as our tallies for how many times it ended up. So I have 1, 2, ended on the open end. 1, 2, 3, 4, ended up on the closed end. These are sets of 5. That line that goes across, that's number 5. So that's 5, 10, 11, 12, 13, 14. So I have 14 there. So I'm going to write the numbers down here. So I ended up with 4 and 14. Okay, so that's what I ended up with. That's my numbers. The top you were supposed to have for B, this is B. A was writing down, well, it could end with the top up. It could end with the open part up. It could end with the closed part up, or it could just end on its side. Now you can tell just by looking at this. Sorry, it was over the thing. You can tell just by looking at this that it is much more likely that it's going to end up on its side than anything else. All right, so when we end up getting all of our information together, we should find it's much more likely that it will end up on its side. And if you tried it yourself at home, you don't have to have the same tally marks that I do. These are my tally marks. Yours can be different. That's fine. I don't care. So number 1 says, what do the outcomes appear to be equally likely? Well, given that it was on its side 14 times and the other ones were only a 2 and a 4, I would say no, not at all. So number 2, describe the 3 outcomes with words such as likely and unlikely. So open end, that was my first outcome. And I'm going to put down that it only happened 2 times. That's unlikely. It's probably not going to happen. Closed end. Oops. That happened only 4 times, so I'm going to put down that no, that's not likely either. That's also unlikely. And finally, on the side, that happened 14 times. 14 out of 20. So I'm going to put down that that is likely. That's actually very likely. All right, so that's likely to have happened. Now I'm going to sit here and I'm going to go over to the little box that they have onto the side. You can go ahead and pause right now if you still need to write because you need more time, but I am moving on. Okay. We will come back to the notes in a little bit because we have a little more to add in with the different ways to show the information, but for right now, I'm moving on to our table. And our table at the bottom shows how to put this into fractional form. So give me just a second. I had forgotten that I needed to make the table. Okay, so I'm back. We now need to fill in the information from the top. My information was the open end up. That would be the top up. If you would put top instead, is 2. The open end down, that would be the bottom. Closed end up. That would be the bottom of the cup was up. I had happen 4 times. And it landing on its side, I had happen 14 times. Now, what it's going to want us to do, the 20 is how many times it was tried. What it's going to want us to do is it's going to want us to reduce these down to simplest form. And I know how much you guys love reducing things down to simplest form. Unfortunately, we're going to have to do it again. All right, so I'm looking at this and I'm going 2 and 20, they're both even. So I can take a 2 out of that. I'm going to take out a 2. 2 divided by 2 is 1 over 20 divided by 2, which is 10. And I can't go any lower. Down here. Now, I could do divided by 2 because 4 and 20 are both even numbers. So I could just divide by 2 again. But I know that 4 goes into 20. And so I'm just going to take out the 4 to begin with. So I'm going to divide out a 4 and divide out a 4. 4 divided by 4 is 1. 20 divided by 4 is 5. All right, so we now have 1/10. We have 1/5. And then down here, 14 over 20. Again, we have even numbers. So I'm going to divide out a 2. Always, 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 always. Divide by 2, divide by 2. 14 divided by 2 is 7. Over 20 divided by 2, which is 10. So I end up with, instead of 2 20ths, 4 20ths, and 14 20ths, 1/10, 1/5, and 7/10. That is how likely it is to happen. So if you throw it 10 times, one of those times, it'll land top up. If you throw it 5 times, one of those times, it'll end bottom up. And if you throw it 10 times, 7 of those times, it'll end up on its side. That's how we read this. That's how we interpret this. So let's go over to the side. Number 4 says what? Number 4 says, what do you think would happen if you performed more trials? Well, obviously, it would land on its side a lot more. Okay, or rather, it would land on its side most often, most of the time. Let's go with most of the time. Most of the time. Would land on its side most of the time. Number 5, what is the sum of the probabilities? Okay, so it wants us to do, for number 5, it wants us to do 2 plus 4 plus 14. 2 plus 4 is 6, plus 14. 6 plus 14 is 20. So we end up with 20. If you need to pause to write, pause. I'm moving on. Okay, next page. I have calculating experimental probability. You can use experimental probability to approximate the probability of an event. And experimental probability of an event is found by comparing the number of times the event occurs to the total number of trials. There's only one outcome for the event. It is called a simple event. Okay, so here we have Martin, who has his bag of marbles. He removed one marble at a time, recorded which color it was, put it back into the bag, repeated it several times, recorded all those results on the table. So now we're supposed to find the probability of drawing each color. So first off, what they did was they added all of the trials together, and then they figured out how many times he actually pulled a marble out. It came out to 50 times that he pulled a marble out. Then they put how many of each kind that they had, so 12 over 50, 10 over 50, 15 over 50, 13 over 50. And then they reduced any of the ones that they could. So let's go down to number 6. What are 2 different ways you could find the experimental probability of the event in which he does not draw a red marble? Okay, so we have already shown it as a fraction. We showed it as a fraction. Actually, no, we haven't shown it as a fraction yet, have we? Because they didn't actually solve for that particular one. Just a sec. Okay, so I'm back. And I have the numbers written down here. Now, I got the 10 because that's how many blues there are, the green, which is how many, 15, which is how many greens there are, and the 13, which is how many yellows there are. The only thing that's left is the reds, which I did not include because it doesn't want to know how many reds there are. It wants to know how likely it is that it's not going to be red. So I'm going to do 10 plus 15, which is 25, plus the 13, which is 38. Okay, so we end up with 38 out of 50 times he will get it. Now, here comes the fun part. This is one way of showing that, 38 out of 50. We can reduce this down if we want to. I'm not going to reduce it down at the moment. But that is not the only way that we can show it. We can also show this as a percent. And you're going to have to give me just a sec to go get a calculator. Okay, so I'm back. I'm borrowing Tim's calculator. Okay, so we need to plug in our numbers. So we're going to do 38 divided by 50, which is going to give us a, okay, so it gave me the least for the fraction, but it simplified my fraction for me. But I can do this. We have this button right here, the S to D. So I press that once, and it gives me my decimal. My decimal is, if you can see it, it is 0.76. So that is our probability. It's 0.76. Or we can change it so it is a percentage of 76%. And at this point, we're going to go back to our notes because we need to add that into our notes. So I need to put in probability can be shown, can be shown as a fraction, a decimal, or a percent. So if it asks for 3 different ways to show it, those are the 3 different ways to show it. It is a fraction, a decimal, or a percent. Typically, the 2 ways that they're looking for, if they're actually looking for it, is they are looking for the fraction and the percent. It's not very often that people are actually interested in the decimal. It's just there. Again, pause if you need to write down. I'm going to move on. Going back to this page. All right, so I am going to go up to number 7. Your turn. It says A spinner has 3 unequal sections, red, yellow, and blue. This table shows the results of Nolan's spins. Find the experimental probability of landing on each color. Write your answers in the simplest form. Well, we already know what our numerators are going to be. It tells us in the table. But the first thing we have to do before we can do anything else is find the denominator. So we have to take all of the numerators, 10, 14, and 6, and add them all together. Okay? So 4 plus 6 is 10, and 1 plus 1 plus 1 is 3. So our denominator is going to be 30. So when we're talking about find the experimental probability of landing on each color. Yeah, so it wants to know every single one of the colors. It wants red, yellow, and blue. And it wants in simplest form. Okay. So red is going to end up being the 10 over the 30. Now I can look at that and I can go, oh, they're both even. I can take out a 2. Or I can look at it and I can go, oh, they both end in a 0. I can take out a 5. I'm looking at it and I'm going, they both end in a 0. I can take out a 10. So I'm just going to take out a 10. So I have 10 divided by 10, which is 1, and 30 divided by 10, which is 3. Whenever you have a 0 at the end of each of them, you can just knock off the zeros. You don't need them. Yellow is 14 over 30. Well, the only thing they have in common is they're both even. So we're just going to have to divide by 2. There's nothing else we can do. So I'm going to divide by 2. 14 divided by 2 is 7. And 30 divided by 2 is 15. Blue ends up being 6 over 30. Wait a minute. Doesn't 6 go into 30? Yeah, it does. How many times? 5. So let's divide by 5. Sorry, let's divide. It goes in 6 times, sorry. So we're going to divide by 6. Oops. Yeah, 6 divided by 5. That'll go well. Okay, so 6 divided by 6 is 1. And 30 divided by 6 is 5. There we go. So your actual answer ends up being red 1/3, yellow 7/15, blue 1/5. Those end up being your answers. And I am moving on to the next part. So you can freeze it there if you need to. Example 2 is just talking about how if they give you a whole ton of information, you can then sit there and make a guess, a pretty good guess. It's called an educated guess based upon the information that you gathered already, which is really what we're trying to do with this experimental probability in the first place. We're trying to make a educated guess about what's going to happen. We don't know for sure. There's always a possibility that something different will happen. But most likely this is going to happen or that's going to happen. That's what this entire thing is about. It's not about there being no possibility of there being something else happening. So let's actually jump down to number 8, which is on 378. And so number 8 says, a toy machine has equal numbers of red, white, and blue foam balls, which it releases at random. Ross wonders which color ball will be released next. How could I use a standard number cube to determine the answer? Okay, so we were talking about the die at the beginning. How many sides does the die have? It has 6. So we have 3 colors, and we have a die that has 6 numbers on it. How many times does 3 go into 6? 2. Right. So what I can do is this. I can assign 2 numbers on the cube, on the die, to each color. Since we have 3 colors, 6 numbers, 2 numbers for each color. It really doesn't matter which numbers. So you could do 1 and 2 are red, or you could do 1 and 5 are red. It really does not matter at all when we are dealing with a die. So I can assign 2 numbers on the die to each color. I can then roll them and see what comes up. It's the best that we can do. I mean, we don't know if there's like twice as many red balls as there are blue balls. It doesn't tell us. It just says there are 3 balls and 3 colors of balls in there. Oh no, it says that there's equal numbers. So if there's completely equal numbers, it's totally random. You can't pick and choose at all. Okay, so let's go down to the guided practice. And I'm actually going to go on to a different page for the guided practice. So if you haven't finished copying that down, pause the video. Okay, so down at the guided practice, I have number 1, we have the spinner. And we are shown the frequency that we end up with on the spins. So it wants us to show the 3 different ways to do it. It wants it as a fraction in simplest form, it wants it as a decimal, and it wants it as a percent. So we're going to have to do all 3 of them. Like I said, if it wants 3 different ways, that's the 3 different ways: fraction, decimal, percent. Okay, so let's see if we can do this. If we can do this, it'll be fine. Okay, so it doesn't tell us how many times they did it. So that's the first thing that we have to figure out before we can figure anything else out. So this is number 1, and we are given the values of 14, 7, 11, and 8. Okay, so I'm going to put the 7 with this 1, and I'm going to say that makes 8. And then go 8 plus 8, which is 16. And then add on that 4 to it. And 6 plus 4 is 10. So I'm going to add that 1 onto the 1 at the beginning of the 16. So I actually end up with 20. That's my line of reasoning for how I'm going through this. So I end up with a 2 at the top. Okay? The 1 plus 1 is 2, plus another 2 is 4. Right. So I end up with 40. That's our bottom number. These are all our top numbers. This is the bottom number. Okay, so we have our different sections. We have A, which is 14 over 40. That's what we start with. We're not allowed to stay there, though. It says simplest terms, so we have to reduce this. What can I take out of both of these? Well, they're even, so I can take out 2. Divide both of them by 2. 14 divided by 2 is 7. And 40 divided by 2 is 20. That's as low as I can make it. I'm then going to get out my calculator. And I am going to go 7 divided by 20 equals, and it tells me 7/20. That's not what I wanted. 0.35 equals 0.35. So that's 35/100ths. That's how we read that. I am going to change it to a percent. So I'm going to move my decimal 2 times. So I now have 35%. B, I'm going to switch my colors. Let's do it in this color. B, I start with 7 out of 40. I can't do anything with that. There is absolutely nothing I can get out of that. So I am going to go straight over here. 7 divided by 40 equals 0.175 or 175 thousandths. I move the decimal point. Now, here it gets tricky. I only move the decimal point 2 times. Doesn't matter how many numbers I have. 2 times, that's it. 1, 2. So that makes it a 17.5% or 17 5/10%. Letter C. I'm going to do this one in orange, I think. Alrighty. We have an 11 over 40. Again, I cannot make that any smaller. That's just what it is. This is going to be a fun decimal. Okay. 11 divided by 40 equals, yeah, don't want that one. Oh, not too bad. 0.275. I thought it was going to be a lot worse. 0.275. Again, we only move the decimal point twice. That's it. I don't care how many numbers there are. So we move the decimal 1, 2. Or actually, that is 275,000. Sorry. So I have 27.5% or 27 5/10%. Letter D is 8 over 40. Well, I can take something out of this. In fact, I know I can take 8 into 40. That one works. That's one of our regular facts. So I'm just going to divide both of them by 8. 8 divided by 8 is 1. 40 divided by 8 is 5. So I end up with 1/5. So again, I'm going to go over to my calculator. 1 divided by 5 equals, well, not what I wanted, 0.2 or 2/10. This one only has the 1 decimal. You remember what to do when we need to move it 2 times and we only have 1 number? You ignore the fact that you only have 1 number and you add in an extra 0. Remember that? We've done that a while. So that equals out to 20%. Sorry. Okay, so that is number 1. Let's look down at number 2. Number 2 says, Rachel's free throw average for basketball is 60%. She wants to predict how many times in the next 50 tries she will make a free throw. Describe how she could use 10 index cards to predict the answer. Okay. So she has 10 index cards. She knows that she has an average of 60%. Let's talk about this for a little bit. So 60% is equal to 60 over 100. That is literally what percent means. Percent literally means over 100. So I can sit there. And remember I said before, if I have zeros on the outside, I can just cross off the zeros. So I end up with 6 over 10. Remember that? We talked about that? Yeah. So I have 10 index cards. How many of the index cards is she going to need to mark so that she can show that she made the free throw? Right there is our answer. So what we're going to write down in the book is, I can mark 6 cards I can mark 6 cards. That's how many cards we're going to mark because that's how many we have. I will then draw a card and replace it 10 times. Each time I get a marked card, it will mean she made the free throw. Should we keep it at 10 times or should we change it to 20 times? They seem to have it going with 20 times an awful lot. Let's change it to 20 times. Repeat it 20 times. Okay? That seems like something they would be more interested in us doing. Okay. So. Number 3, the last one on the guided practice, anyway, it's been taking a very long time, is how do you find an experimental probability of a simple event? So, experimental probability of a simple event. Pause this if you want to copy it down. I actually have a little bit of space left on the bottom of one of our earlier sheets, so I'm just going to go back and use up that space. All right. You know what? I'll just put this on top of it. No, that shows through. Okay. Yeah, see, this is from before. But at the bottom, we have space, so I'm just going to use that space right there. Okay. Instead of getting out a whole new sheet of paper for answering a single question. How do you find the experimental probability of a simple event? Well, you can set up a test for it and try it out a couple a certain number of times, a certain number of times. Yeah, that's about all that you can do for that. I'm going to put that there. And if you need to pause it, that's fine. So that's where I'm going to stop with this particular lesson. I know that you also have 12.3. I'm going to be putting up 12.3 in a bit. So I hope that was helpful. See you later, guys.